working with graphing different types of functions and kind of transforming. No, we're going to be transforming different types of functions on a graph. This is what this is. This is a graph. And so, firstly, let's identify, as we always do, using decimals, by the way. We have f of x equals x plus 1 squared. So there we go. Firstly, I think we should sort out what this f of x means. F of x, basically, it just means there's a function. Okay, f of x means there is a function. This is going to equal a function. Something in this little loop right here, it's functioning, it's working. And then x plus 1 squared. This might remind you of factoring, maybe a little bit. Yeah, it might remind you of factoring, maybe even quadratics a tiny bit. Keep that in mind. Keep that in mind. Anyways, you have to work on solving this. Firstly, I will say that order does matter, and let me just explain that before we go looking at different types of rules and stuff. So think of it as PEMDAS. When we have PEMDAS, we have please excuse my dear Aunt Sally. So we're going to be doing everything that's in the parentheses first. It's everything that's going on here, and then as well as what's going on the outside, multiplication, and then plus or minus, and that is actually going to play into a factor of this. Hold on, let's go look at this chart. Okay, so which one of these is going to look like our equation right here? We have translating up or down, g of x equals f of x plus x, which would look like something x squared plus 4 plus 5. That is obviously going to be out of the way, it does not look like that at all. And then we have translating left to right. Now our entire problem is asking us to translate to the right by 5 units, and then also do a little bit of reflecting over the x-axis. So it's more than likely gonna look like this. Translate to the right, g of x equals f, and then x plus k, which k, let's explain that. K being our number, essentially, what's going to be inside the parentheses, whether it's plus or minus, x, and then the example is going to be x plus 5 squared plus 4. Now this actually does what we're working with. We have the x plus 1 squared, we just don't have the 4 on the end, but that is okay. We do know we're going to be moving over to the right by 5, so let's count this up real quick. Moving to the right, but which way is right? So let's talk about that. When we have x, we have f and then x plus k, we're going to be adding the value to that value of k to x, of course, and then left is going to be everything on this side over here, and right is going to be everything on this side. So essentially, right is negative and left is positive, even though it's kind of messed up when looking at the graph. So let's say we wanted to move over. I'm going to go by every point, just every marker right here. 1, 2, 3, 4, and 5. So just so we can make this a little bit clearer, how do I zoom in enough though, just so that it's visible? Well, as you can see, this is gonna be 1. All of these are like little ones, just so you know. I think it already showed that. Yes, okay, it does. So that's gonna be -1, but basically we're gonna be going in and kind of working with this, so that will be 1, 2, 3, 4, 5. So it's going to move over to the right, over to +4, and let's just start another equation right here, just so I can visually put this on the map. Loading. There we go. Okay, so now we have our new line. So now we're gonna be adding this -4, and that would essentially look like that, but I'm gonna write it as this, and you still get the same answer. So that will be moving it over to the right by 5, since we started off with this -1. And then we're going to work what's outside. So we want it to flip across the x-axis. We want it to reflect across the x-axis. How are we going to do that? Well, there's a rule. Basically, you're going to multiply the entire function by -1. Okay, don't ask, we're just going to be multiplying it by -1 to flip that entire thing. So, what you can do is you can just write it like this, and this will work. Well, you could write it like -1, but we don't really do that. We kind of just write it as negative, and then that just kind of does it for you. Oh, I zoomed in at the wrong place. Okay, and there we go. Now you can see the ones a little bit. So yeah, that would be our -1. Don't have to write it, just write it like that. It'll be fine. And yeah, that is just essentially how you transform this to this. You want it to flip. You know what? I should probably show this just for reference. Yeah, this will be good. That would be basically negating over the x-axis, and that actually would look like something we did right here. So it would be -x to the second plus 4. So essentially, this is what you need. This is all you need to do if you just want to, transform it, going 1, 2, 3, 4, 5, and then just flipping it by multiplying it by 1. That is literally all you do. That simple. There are a lot of other ways. Well, no, not other ways, but there are a lot of different things you could have done. But that is gonna be the number one way. And then let's see, what else can we say? Oh, yeah, I should probably explain this. When the parabola is facing up, it's going to be positive. When the parabola is facing down, it's going to be negative. And, that is all. This positive, this negative. If you didn't already see that, that is also important to note. And then, yeah, that's basically it. That's all you need to know. I should probably explain that last number since we didn't do that actually. So basically, when adding a number at the end of a function, it goes up or down. Let's reference back to the chart. Up is going to be plus, and then down is going to be negative. And that will basically be this one up here, the one we were talking about. So that will be up this way, or it would be down this way. Just to close that off, just so